Hey pre-calcers, we're eventually going to get into Chapter 5 with 5.1, verifying trig identities. Before we get into that, I wanted to show you this quick clip from a movie called Carlito's Way. If you've seen Scarface before, it's that same director. It has Al Pacino in it, also Luis Guzman. And I thought that this was an interesting movie to open up with, and I'll show you in a second. Just this opening scene. So we see Al Pacino's character on the train, and what we inevitably see is pretty much the ending of the movie, but it starts right at the opening scene. I thought that this was an interesting way to open up because with 5.1, we're eventually going to see the final, we always have the final answer given to us at the very beginning. And our goal is to just kind of figure out what happens in between the beginning and the final product. Similar to that movie, it starts with the ending, like here it is, this is what's happening, and you kind of have to work back from there to watch the whole movie and see what happens. So with an identity, we'll start off by saying that we have two sides of an equation that are considered true. Again, the final answer can kind of be seen here on the right. Problems like this would say, all right, well, your answer is 21, or it could be 3 times 7, or they might say that your final answer is x plus 3, x minus 3, and that's just the factored form of x squared minus 9. As we move forward, these basic properties, basic identities they call them, pretty much everything that's here is going to be important. So I would actually take a moment and copy all of this down and pause the video. So make sure you copy that. You should have paused the video already. All right, let's get into it. What have we seen so far? We have seen cosecant is 1 over sine of theta. That's what this little 0 is, theta. We've seen secant, we've seen cotangent, we've seen sine, not necessarily expressed in this way, but we've seen sine before, where we can say that that's the reciprocal or the inverse of cosecant. Cosine we've also seen. Sorry about that. So for the most part, we've seen all of these. And our agenda for this section is to try and identify different situations that deal with trig and rewrite them until they end up as the final answer that's given. This can be a little complex, but all of these characteristics are really important, so please take note of them. Tangent of theta is another way that we can rewrite sine of theta over cosine of theta. And if you think of this in the flipped role, think of how cotangent and tangent are related, inverses. Here they're saying that cotangent of theta is simply cosine of theta over sine of theta. So notice that these are flipped around. And the reason we're going through so many of these right off the bat is because we're going to see tons of these problems where we have a complex trig equation at the beginning, and we want to rewrite it as much as we can using all of the knowledge we have about trig and the ways that it can be rewritten. We then go into Pythagorean identities. These are important, saying that if we have sine squared of theta plus cosine squared of theta, that's equal to 1. Sometimes we'll just be given cosine squared of theta, and we should also note that that's equal to 1 minus sine squared theta. Because notice you can just subtract the sine squared theta from 1 and the left side. We see 1 plus tangent squared of theta equals secant squared of theta. Another way this could be interpreted is tangent squared of theta equals secant squared of theta minus 1. So that's another way. We also see 1 plus cotangent squared of theta equals cosecant squared of theta. We don't see too much, honestly, of this even and odd trig functions, but here they are. We might need to refer back to those. And so let's read this off here. There are formulaic relationships which interrelate the trig functions together, and there are several ways that we can rewrite a trig function. We've seen trig before. Now we're getting a little bit more complex with it. And so we see different ways that we could express the same trig function. Notice that we could just write sine of theta, or we could write 1 over cosecant of theta. So we see lots of different ways to write the same type of function. In this example seen here, tangent of theta we could rewrite as sine of theta over cosine of theta. We saw from the very beginning that sine of theta can be rewritten to 1 over cosecant. Cosine of theta can be rewritten to 1 over secant of theta. We can then treat this as if it's multiplying with this reciprocal. So notice that if we flip over 1 over secant of theta, that gets us to here. And then if we just multiply that across, 1 times secant of theta gets us secant. Cosecant times 1 gets us cosecant. So this would be our final answer. So notice this is a bit more complex than the sections we've seen so far. As we move forward, these are some tricks and some things that you should recall that are ways we can rewrite these trig identities. Using algebra, we might have to do a bit of factoring, a bit of foiling, maybe even distribution or undistribute a common trig function that we see. We'll definitely have to deal with trig, and again, that page at the very beginning is super pivotal. And sometimes you just have to be crafty with how you come up with these answers. Again, the answer is usually given to us, and we're just showing the work that would allow us to say this starting point on the left is equal to the starting point on the right. And what they call this type of strategy is brute force, because we're just plugging in and just kind of going through all of our options first to rewrite as much as we can and get that final answer. Good rule of thumb is that we will most likely be rewriting terms in sine and cosine. So be on the look for any situation where we can do that. Let's start with this first one. So we're verifying that sine of theta, when multiplied with cotangent of theta, is equal to just cosine of theta. Well, as mentioned here with the step, we should try and write everything in sine and cosine. So let's do that. I know from the very beginning, cotangent of theta, how can this be rewritten? What do you think? Well, at the very beginning, we saw that cotangent of theta could be rewritten as cosine of theta times sine of theta. And that's all we can say about that. We know that sine of theta was still over here. And since the right side's a fraction, let's keep this dividing by 1. And we're inevitably going to say that this is going to equal cosine of theta. So let's think this out. We have sine of theta here multiplying with this fraction. Do you see anything that can cancel? Hopefully you're saying that these sine of thetas can cancel. And if you're not convinced, think of this out. You'd be multiplying sine of theta with cosine of theta for the top. 1 times sine of theta gets rewritten down here. And then now this may be a little bit easier to see why sine of theta and this sine of theta can cancel, leaving us with our final answer, which was what we wanted, claiming that cosine of theta equals cosine of theta. And this final step is a good move because it shows that we rewrote the left side as much as we could to inevitably get that cosine of theta, which again was handed to us right at the beginning. All we had to do was fill in the gaps. What else do we got? We have to verify 1 minus cosine of theta over secant of theta equals sine squared of theta. Okay, what do you think we can rewrite? Well, 1, that's same as it ever was. Cosine of theta, can't do too much with that. What about secant of theta? Can you rewrite that? Secant of theta, recall, we can rewrite as 1 over cosine of theta. And we're eventually going to say that this is equal to sine squared of theta. It's a good rule of thumb and a good strategy. Just keep rewriting what it's equal to for the final answer. All right, so this looks a little complex, so let me walk you through this. We have this single fraction where cosine is up top, So we have cosine of theta over 1. And this is multiplying with our reciprocal here. And if we flip that fraction, what's that going to look like? You should be saying cosine of theta over 1. And don't forget that we're still subtracting that, and 1 is still in the front. And this should be claiming it's equal to sine squared of theta. Cool. Well, let's multiply these two out. Cosine times cosine, those can go up an exponent. And that leaves us with just cosine of squared of theta, claiming this is equal to sine squared of theta. And if we recall back on our Pythagorean identities, so this is referencing those. I think I rewrote this one at the very beginning. So this is referencing the Pythagorean identity, which says that 1 minus cosine squared of theta equals sine squared of theta. So now these are equal, and we're done. I think we got time for one more. Yeah, let's do this. So we have cosecant of beta. So this little b here is now for beta. We can still treat this as if it's sigma. So cosecant of beta minus sine of beta equals cosine of beta over tangent of beta. Cosecant, we can definitely rewrite that. It's 1 minus sine of beta. Sine of beta, you can't do too much. Cosine of beta, we'll leave that. Tangent of beta, we'll leave that too. I try not to change the final answer. I really just try to focus all of my energy and work on the left side. So I'm just focusing on the left side for now. All right, so we have this setup here. Do you think that we can rewrite what's going on here? Well, we could rewrite this sine of beta as sine of beta over 1. We can then try to get common denominators because we're dealing with fractions here. So that should seem pretty feasible, right? So let's multiply our left side, or actually we can just cross multiply. So sine of beta is now being squared on the right side. And this leaves us with sine of beta in our denominator. And if we distribute the 1 here and here, that doesn't change too much. And that now gets us to here. All right, so we're now kind of stuck. We can't do a ton. It almost looks as if we made this more complex, but trust me, we can get through this. Let me just finish off this last part here. All right, so 1 minus sine squared of beta, can we rewrite that? We could. So cosine squared of beta over sine beta. And this is still claiming that it's equal to cosine of beta over tangent of beta. This seems as if we're still stuck. We're close. We're almost there. We see cosines up top, but this only has one version of it. All right, so what can we do? Cosine of beta squared we can rewrite as cosine beta times cosine beta over just one version of sine of beta. That makes sense, because if we just multiply it across, it would get us cosine squared up top, sine still in the bottom. So cosine of beta and over sine of beta, we can rewrite that as 1 over tangent of beta. Cosine of beta is still here. If we multiply these across, this gets us to cosine of beta up top over tangent beta, which makes both sides now equal, which is what we want. I know that this seems complex. It is. If you have the first set of notes down, if you keep looking back at them, almost keep them on the side for this section, you should be okay. I'm probably going to post more examples